All right, so now let's move on to compound inequalities. So what we just looked at was the intersection and the union of sets. And now what we want to look at is the intersection and the union of inequalities. Now they call them compound because it's two inequalities that we're going to use together. So you have to keep in mind the word intersection goes with the word and the word union goes with the word or. And even further, if you want to, intersection goes with the N or the upside down U, and union goes with the upright U. So let's start off objective 3. Let's just solve compound inequalities that has the word and. So step number 1, you're going to solve each inequality individually. So you're going to take it to the place where it's just x is greater than or less than or equal to a number. Then step 2, because the inequalities are joined with an and, the solution set of your compound inequality will include all numbers that satisfy both inequalities. You're looking for the intersection of your two inequalities. I think of this as where the graph solutions overlap. So for example, if we have x is greater than -3, that is -3 is the smaller of the two numbers, and then we've got a 5 here. If I want to draw x is greater than -3, I'm going to do a round bracket opening to the right. Then I'm going to use a different color, and I'm going to graph x is less than 5. So x is less than 5 is a round bracket opening to the left on 5. Now, because we're talking about the numbers that satisfy both inequalities, right? So they have to be and, you're looking for where the two graph solutions overlap. In other words, there has to be a blue line and an orange line. So the solution to this inequality or this compound inequality would just be -3 to 5. Okay, those are the only numbers that are greater than -3 and less than 5. So for example, 0, right? 0 is greater than -3 and it's less than 5. If you tried to pick something over here like -4, -4 is not greater than -3. So even though it's less than 5, it doesn't satisfy both of the inequalities. Okay, let's move over here and start with even a different color for my number line. So I'm going to draw my number line. I'm going to put my -3. I'm going to put my 5. Okay, so first off, this time I'm graphing x is less than -3. So it's going to be a round bracket opening to the left. And then I'm graphing x is greater than 5. So x is greater than 5. So are there any numbers that are less than -3 and greater than 5? Do these two graph solutions overlap at all? No. So what's the solution to this one? Well, the solution is that there is no solution, right? Empty set or null sign. There's no number that's less than -3 and greater than 5. There's no overlap. All right, let's look at scenario number 3. Scenario number 3. Draw my number line, put on my -3, put on my 5. All right, so first off, we're going to graph what? X is greater than -3. So greater than is a round bracket opening to the right. Now, in orange, we're going to graph x is greater than 5. So round bracket at 5, and again, opening to the right. Are there any numbers that are greater than 3 and greater than 5? Is there anywhere my graphs overlap? Well, yeah, just here. So the only numbers that are greater than -3 and greater than -5, are the values that are greater than 5. So all the numbers like 6. 6 is greater than -3 and it's greater than 5. 7, 8, 9, and so on. All right, if you feel like you've got this, try this next one. Otherwise, just keep watching with me. So this is my last scenario. My last scenario, I'm going to put on my -3. I'm going to put on my 5. Go back to blue. This one wants me to graph x is less than -3. So a round bracket opening to the left. And it also wants me to graph less than 5. So round bracket opening to the left. The question is, are there any numbers that are less than -3 and less than 5? Well, the only place we overlap is here. Only the values that are less than -3 will make this compound inequality true. So these are my 5 scenarios for and. So first scenario, we had, the arrows going in opposite directions, so it was a sandwich. All the numbers between -3 and 5 were the solutions. Then we had scenario number 2, where both arrows went away from each other, and they don't overlap, so there's no solutions. And then scenarios 3 and 4, you had the arrows going in the same direction, but you could only take the parts of it where they overlap. So when it was greater than, you had to pick the higher number, and when it was less than, you had to pick the lower number. So now we're going to do one from scratch, or two. So I've got 2 scenarios here, and I haven't done the first step yet, so I haven't isolated x. So let's start with that. So for the first one, I'm going to subtract 3, and I get x is less than -2. For the second one, I'm going to add 4, and I get x is greater than -8. So again, just be careful. Do I have to flip any inequality signs? No, I'm good. So now I like to graph them, right? I do not like solving compound inequalities without a graph. So -8 is my smaller number, -2 is my bigger number. So when you go to your number line, graph them in order. So now let's graph x is less than -2. So less is to the left with an arrow going all the way down. Then let's graph x is greater than -8. So greater than is to the right, still a round bracket, and opening to the right. So since I'm using the word and here, okay, I'm looking for where my arrows overlap, which is only this middle section. So it's from -8 to -2 inclusive. So that is the answer to my compound inequality, and I answered in an interval notation. I did that because the back of the book always answers in interval notation. In fact, if I think correctly, I think the back of the book gives you the graph and the interval notation. So they would actually put -8, -2 round brackets and just show the part in the middle, right? So that's the graph of the solution. I would accept this as a graph as well because it's showing that overlap and how you got to your interval notation answer. All right, if you haven't paused the video yet, now would be a good time. So I want you to solve this compound inequality. So what am I going to do? I'm trying to decide if I want my x's on the left or the right. So personally, I would probably put them on the right. I hate flipping the sign, but I'm going to go to the left just to make myself do something I don't like. So I'm going to go -4x. So I'm going to get -2x is less than or equal to 8. Then I'm going to divide both sides by -2. When I do that, I'm going to remember to flip my inequality sign. So I end up with x is greater than or equal to -4. Then I'm going to do the same thing here. This one I just have to divide by 3, and I get x is greater than or equal to -3. Then I like to graph my solution. It's the only way I can see my inequality, my compound inequality. So what's the smaller number? -4, bigger number -3, and I'm going to graph them separately. So x is greater than or equal to -4. I need to remember my square bracket, and greater than is to the right. If you're afraid you've messed this up, pick a number greater than -4 and plug it in to make sure it's true, like 0. Is 0 less than or equal to 8? Yeah, okay, I'm good, right? And then I'm going to check this one too. So x is greater than or equal to -3. So again, that's opening to the right with a bracket. So where's my solution? Well, anywhere that they overlap. So it's going to be from -3 with a square bracket up to infinity. Now again, on that line of checking, if you wanted to check this was true, you should be able to pick a number greater than or equal to -3. You could choose -3, or you could choose 0. I like choosing zeros when I can. But what's going to make it work is that when you plug it into the original equations, it makes both of them true. So we already checked 0, so let's check x equals 0. So we check it into the first equation. 2 times 0, is that less than or equal to 4 times 0 plus 8? Well, 0 is less than or equal to 8. Yeah, it's good. But it has to satisfy both. So let's check 3 times 0. Is that greater than or equal to -9? Well, is 0 greater than or equal to -9? Yeah. So something in this interval satisfied both equations. All right, so go and practice your intersection of a compound inequality.